In this video, we will talk about the derivatives of the functions f of x equals c and f of x equals x. So our goal is to get shortcuts for what these derivatives are so that we don't have to use the limit definition of the derivative every single time we do a derivative. So let's begin with the derivative of a constant function. So that's when we have f of x equals c. And when we say that c is a constant, that means that this is some fixed number. So some fixed number, like f of x equals 3 or f of x equals negative pi. So whatever c is, it's some fixed number. It's not changing. So we can actually derive a formula for this geometrically using the picture. So if I draw a picture of a constant function, so let's draw our axes. So constant function, f of x equals c, that looks like a line. It's a horizontal line that goes through c on the y-axis. So it goes through c on the y-axis. And if I want to know what the derivative is at some point x, so if I look at that point on the graph, well, the derivative tells me the slope at that point. But I can tell what the slope is just by looking at this. The slope of the tangent line at my point is 0. And it's not hard to see that no matter what point we were to take on this graph, the slope of the tangent line is always going to be 0. Because the tangent line, if we were to draw it, will go through that point, and it has to sort of match how steep the graph is at this point. But my graph is a line, so my tangent line should be able to perfectly replicate or sort of perfectly approximate what my graph looks like. So that pink thing, that pink line is the tangent line. So I've drawn the tangent line on top of the original function. Okay, so we can say what the derivative is, what f prime of x is. So remember, the derivative represents the slope. F prime of x is 0 because the slope at any point, just by looking at this picture, is going to be 0. All right, so I want to introduce some notation to talk about derivatives that we can use instead of using this prime notation. So the notation is we write d dx, and d dx is what's called a differential operator. And that means, so what d dx means is, it means take the derivative with respect to x of ... And I'll put ... because we don't write d dx on its own. We write d dx, and then something goes after that. Okay, so an operator is something symbolic in math. And it sort of connects other things. So another example of an operator is a plus sign. It's a symbol that has some meaning, but it's not just written on its own. There are other things written with it, like with an addition sign, we put two numbers on either side of it, and that gives it meaning now. So similarly with d dx, it's not just going to be written on its own, there's got to be something with it. So in our example here, we could write d dx of c, and that now means the derivative with respect to x of c is, and we just saw that the derivative of the constant was 0. All right, so let's go ahead and box this. So what does the whole with respect to x mean? Well, that just means that x is the variable in the function. So we'll see situations later in the course where y might be a function of the variable x, and x might be a function of a different variable t, so they're sort of going to be functions within functions. And when we have that, when we have more than one variable floating around, it'll be important to distinguish what variable you're actually taking the derivative with respect to. Okay, but in this case, there's just one variable within my function, it's the x, and I'm taking the derivative with respect to that. Okay, so the derivative of a constant is 0. What about the derivative of the function f of x equals x? I can do this in the same way. I can determine this derivative using a picture. So let's draw a picture. So the graph of f of x equals x. I'm actually going to pause the video and leave this for you to try. So I'm going to pause it for 1 minute, see if you can draw a really similar picture to what we did with the constant, and derive a formula for this derivative, purely graphically. 4, 3, 2, 1, pause the video. Pause the video for 1 minute and see if you can finish this in the same way we did the example above. Alright, so hopefully you've done that. Hopefully you've paused the video to try this for a minute. So the graph of f of x equals x, well, that's the same thing as y equals x. So y equals x is a line through the origin, and the slope is 1. And if I were to take any point on the graph, let's say we're the x coordinate, I'm just going to call it x, and I look at this point on the graph, I can determine what the slope is really easily just by looking at it. The slope of the tangent line at any point is 1. So f prime of x for this function, which is the slope of the tangent line, is 1, no matter what point you take on the graph. So using our ddx notation, we'd write ddx of x equals 1. And actually, now that I think I used a different phrasing above. Here I said the slope of the tangent line at any point is 1. Any point on this graph, the slope of the tangent line is 1. Let me just use that same language here. Here I said the slope of the tangent line at my point. Let's just change this to at any point. Because it's not just true for this point that I've drawn, it would be true for any point on that graph. Alright. So when my function is linear, so a constant function had a graph that was a line, f of x, its graph is a line, it's easy to write down what the derivative is, because the slope of the tangent line is just the same thing as the slope of the line. So I can even generalize this and say, in general, if f of x is something linear, so it has the form mx plus b, that implies that the derivative, actually let me use my ddx notation, the ddx of mx plus b is just the slope of that line. Alright, so in the next video, we will talk about some other derivative rules that'll give us shortcuts to take the derivatives of functions that are not linear, so that are more complicated. In terms of our goals, we have now derived rules for the derivatives of a constant function and the function f of x equals x.